All right, guys, let's focus in, focus in. You need a note sheet from yesterday. Need your note sheet out from yesterday. So what we went over yesterday, we started out by solving these quadratic equations by graphing. We were able to use the graphing calculator to plug them in and graph. All right, guys. So we're able to plug them in and graph and find the solutions.
Number 17.
So, guys. All right, guys. So, we solved by graphing. We would plug it in the graphing calculator. We were wanting to find the values of x that would make the y value be 0. We're trying to find the values of x that will make the function be 0. And we worked through some problems yesterday using the graphing calculator and graphing these to find out what values of x would make the function be 0. After we did those there, we worked through solving by the square root method. Now, the square root method works if we have one of two setups. The only term or variable that we have is our x squared term. We just have x squared. We do not have an x to the first term, or x term. Because if we had 3x squared minus 9x, this would not work by the square root method. We can only have an x squared term, or the only variable showing up in the set of parentheses squared. We need it in one of these two cases. Now, we did this one yesterday. We'll go on and just kind of walk back through it again. Because when we use the square root method to just solve by the square root method, the first step is get the term being squared by itself. And in this case here, the term being squared is x squared. So we need to get the x squared term by itself. And the first thing we can do in getting the x squared term by itself is to add 9 to both sides. So our negative 9 plus 9 will simplify out, leaving us with 3x squared is equal to 0 plus 9 is 9. Now, the x squared term is not by itself yet, so we still have to divide both sides by 3. And 3x squared divided by 3 is going to be x squared. 9 divided by 3 is going to be 3. So here we've done the first main step. The first main step is to get the squared term by itself. Our second step is to take the square root of both sides. And we'll have to add the plus or minus, because whenever we take the square root of both sides, we have to put plus or minus, because what's being squared could be positive or negative. Because here we're going to take the square root of both sides, since we got the squared term by itself. Now, the square root of x squared, we're trying to find what times itself is x squared, and that would just be x. On the other side, since we did take the square root of both sides, we're going to add the plus or minus. Now, at this point here, we need to find the square root of 3. We need to figure out what times itself is 3. Well, there is no integer number, no nice number that multiplies by itself to give us 3. So we'll just simplify it, and it ends up just being the square root of 3. Now, the 30xs is very nice with simplifying radicals. We can just type that in, square root of 3, and see if it simplifies. And here it doesn't. It's just the square root of 3. So what it tells us at this point here is that x is equal to plus or minus the square root of 3. That brings us to the last step, and which is to solve for the variable. We need to get the variable by itself, and here x is indeed already by itself. So our solution for here is that x is equal to plus or minus the square root of 3. And that's all we have to do on this one here. We have it solved. Now, this one here would be one of the cases where trying to solve by graphing won't work, because it's not going to intersect at a nice spot. The square root of 3 is not a nice number. It's an irrational number. It has a non-repeating, non-terminating decimal. So here we would solve this by the square root method. Questions on this here? Be ready for the next one. So this next one here, we have 2/5 times x plus 3 squared is equal to 5. Now again, we can do this by the square root method because the only place where the variable shows up is inside the set of parentheses being squared. We can use the square root method if the only variable we have is being squared. We only have x squared. We don't have x to the first. Or the only place the variable shows up is inside a set of parentheses being squared. Now, if we had the other side being 5x, or we had a variable, an x term outside of these parentheses being squared, we could not just solve it by the square root method. We'd have to actually simplify those parentheses out and solve from there. But since the only place the variable shows up is inside that set of parentheses squared, we can still use the square root method steps. And the first step in solving using the square root method is to get the squared term by itself. And here the squared term is that x plus 3 squared. That whole thing, we need to get it by itself first. So the first thing we would see is if there's anything added or subtracted to it. If there is, we move it to the other side. And for this one here, there's nothing being added or subtracted to that x plus 3 squared. So we don't have to worry about moving it over. But it is being multiplied by 2/5. So to undo this multiplication, we're going to divide both sides by 2/5. Because 2/5 divided by 2/5 is going to become 1, leaving us with x plus 3 squared. On the other side, we have 5 divided by 2/5. We can do this by hand, or we can take a calculator and say 5 divided by 2/5 is 25/2. Questions on this so far? So again, our first step is to get the squared term by itself. Do we have the squared term by itself now? Yeah. Because the squared term is the x plus 3. Even though we do have x plus 3, the whole thing is the squared term. It is by itself. And since it is by itself, we can now take the square root of both sides. Because if we look at the square root of the left-hand side, we have the square root of x plus 3 squared. Well, the square root and square will cancel here, leaving us with x plus 3. On the right-hand side, we're going to take the square root of 25/2. So we're going to have to take the square root of the top and bottom, rationalize the denominator, and work it out. Now, if we want to use the calculator and let it help us, the main way that the 30xs will rationalize it, simplify this, is we do have to break it up. Now, no matter how we type this into the graphing calculator, if we type it in as the square root of 25/2, it will give us a decimal. If we break it up, not there, into the square root of 25 over the square root of 2, it will still give it to us as a decimal. The graphing calculator will always give us a decimal approximation. We do not want the decimal approximation. So we're going to use the 30xs. Because our yellow calculator will actually simplify the square root of 25 over the square root of 2. It will simplify the square root of 25/2 into simplest radical form. But to do that, we had to take the square root of 25 over 2 and break it up into the square root of 25 over the square root of 2, which simplifies to 5 square roots of 2 over 2. Questions on this here? And we want want to simplify this as far as possible. Now, if it worked out nicely and it simplifies down completely, that's great. It would simplify down, and then we would go from there. Questions on this so far? At this point here, we've done steps 1 and 2. Our third step, we need to solve for the variable. Now, this is the first one we've seen where the variable is not by itself. So what we have to do is get the variable by itself. And to do that, we're going to subtract 3 from both sides. Because our 3 minus 3 here will leave us with x by itself is equal to. Whenever we have this plus or minus a term, we're going to take this term that we're adding or subtracting and putting it in front of the plus or minus. So we're going to say that we have negative 3 plus or minus 5 squared roots of 2 over 2. We use plus or minus to be able to simplify this into a single expression so we don't have to break it up into 2 separate statements. That x plus 3 is equal to 5 squared roots of 2 over 2, and x is equal to, because we're not wanting to, essentially what we're having to avoid or avoiding is when we square both sides, it's having to rewrite it as 2 separate statements and solving them individually. The plus or minus gives us the ability to write these 2 statements as an individual expression. We can combine them with the plus or minus. But when we do this and we add or subtract, we have to put that number in front. We have to put that number in front of it to know that we have negative 3 plus 5 squared roots of 2 over 2 and negative 3 minus 5 squared roots of 2 over 2. Questions on this here? Questions on anything we've done so far? Now, before we can say we're finished with this here, is negative 3 and 5 squared roots of 2 over 2, are they like terms? No, because one of them has a radical, the other doesn't. They don't have like terms. We cannot combine them. We cannot simplify them. That is the final answer. We're going to leave it as this here because since they're not like terms, we can't add or subtract. If they are like terms, we're going to add them. We're going to subtract them. We're going to simplify. Questions on this here? Questions on anything we've done so far? Let's look at the next one. 2/3 x squared plus 14 equals 20. 2/3 x squared plus 14 equals 20. Now again, we could use the square root method. Now the main reason we know we can use the square root method is the only variable we have in this equation is x squared. We don't have x to the first power, 5x. We don't have an x term. We just have the x squared. Since the only variable we have is x squared, we're going to get it by itself first. So the first thing we can do in getting the x squared term by itself first is to subtract 14 from both sides. Now on the left side, our positive 14 minus 14 is going to 0. So that leaves us with 2/3 x squared equals, well, 20 minus 14 is indeed 6. Is the x squared term our squared term by itself? Well, no, it has the 2/3 with it. So how would we simplify the 2/3? We would divide both sides by 2/3. Now 2/3 x squared divided by 2/3 is going to be x squared, because anything divided by itself is 1. Now we still have to divide 6 by 2/3. Luckily, we can let the calculator do 6 divided by 2/3. 6 divided by 2/3. And it tells us it is 9. At this point here, we would have to square root both sides because our squared term is indeed by itself. Now, the square root of x squared is going to be x equals. So plus or minus, because whenever we take the square root of both sides, we have to add the plus or minus. Square root of 9, 3. Because 3 times 3 is 9, and negative 3 times negative 3 is still 9. So we have positive or negative 3. Is the variable by itself? Yes. So we're done. We're not having to solve because the variable has already been solved for. Questions on this here? Questions on anything we've done so far? Negative 2x squared plus 1 equals negative 6. So again, we can use the square root method on this here. Because the only variable we have is the x squared term. We don't have an x to the first power. Because if this had been negative 2x squared plus x, we can't use the square root method because we have our squared term and x term. But since we can use the square root method, the first thing we need to do is get the x squared term by itself. So the first thing we can do is subtract 1 because our 1 minus 1 would be 0, telling us negative 2x squared is equal to negative 7. What can we do next? Oh, we can divide both sides by 2, but more specifically what? Negative 2. Because our negative 2x squared divided by negative 2 is going to be x squared. On the other side, we have negative 7 divided by negative 2. Well, 7 does not divide by 2 nicely, so we will leave it at 7/2. But our negative divided by a negative makes a positive. So we're saying that x squared equals 7/2. Now the x squared term is by itself, so we can take the square root of both sides. Square root of x squared is x equals plus or minus. Now square root of 7/2, we do need to simplify this. And most likely, y'all are going to use a calculator. If we're going to use the yellow calculator, the 30xs, we're going to have to break it apart so that it'll simplify the radical for us. So we can come over here, break it up, say we want to simplify the square root of 7 over the square root of 2 is the square root of 14/2. Telling us that x is equal to plus or minus the square root of 14 over 2. Since x is indeed by itself, this is as far as it goes. Again, if we're not sure that we got the correct answer, we can always go back and check it. So we're saying negative 2 times the square root of 14 over 2 squared plus 1 should equal what? It should equal negative 6. So the first thing we can simplify is our square root of 14 over 2 squared. Parentheses, second square root of 14 over 2 squared is 7/2. And if we do negative 2 times 7/2, we get negative 7. And negative 7 plus 1 is indeed negative 6, just like we wanted. Well, the other case is if the square root of 14 over 2 was negative. So we can say negative 2, parentheses, negative square root of 14 over 2 squared plus 1. So the first thing I'd calculate is the square root, parentheses, negative square root of 14 over 2 squared is still positive 7/2. And we multiply it by negative 2, we get negative 7, and negative 7 plus 1 is still negative 6. Both work. When we plug them back in, we got true statements. They did work out. Questions on this here? Be ready for the next one. 2 times x minus 4 squared equals negative 5. Now we can still do the square root method for this here because the only place the variable is inside that set of parentheses being squared. So the first thing we can do is get that set of parentheses by itself. Now, first thing I'd be looking at doing is trying to add or subtract numbers from both sides to get the parentheses by itself first, then do our multiplication division. Here, the first thing we can do is divide both sides by 2. Telling us that x minus 4 squared is equal to negative 5 halves. Is our term being squared by itself? Well, yes. So at this point here, we can take the square root of both sides. And on the left-hand side, our square root and square would cancel, telling us x minus 4 is equal to plus or minus. Well, we need to find the square root of negative 5 halves. So we can break it up into its two parts. We can say the square root of negative 5 over the square root of 2. Is a domain error. Now the reason it's saying a domain error is because we're trying to find a number times itself that is negative 5 halves. If we multiply two numbers together, a positive times a positive is still a positive. If we multiply a negative by itself, a negative and negative make a positive. So is there any way to find a square root of a negative number? No, there is no number times itself that gives us a negative. So what that's telling us is this doesn't exist, that there is no real solution for this here. There is no real number that works for this here. There is a solution, it's just not a real number, and we will start talking about that tomorrow. So there is solution for this. There are values that work for this here. They're just not real solutions. Questions on this here? Questions on anything we've done so far? All right. We're going to solve 3 more. We're going to solve them by factoring and seeing some with graphing again. But this one here, we're going to solve this by factoring. Our x squared minus 4x equals 45. We've done factoring. We did it before fall break. When we solve by factoring, the first thing we need to do is get the equation equal to 0. Really, when solving these quadratics, these higher degree polynomial functions, all but 2 methods require us getting the equation equal to 0. One of them is the square root method. We did that one today. And the other is going to be completing the square. We haven't got there yet. But the first thing we can do in solving this by factoring is to get this equation equal to 0. So we can subtract 45 from both sides. Now our 45 minus 45 is indeed going to be 0. And what that tells us is the equation is x squared minus 4x minus 45 is equal to 0. Now at this point here, we can start factoring the left-hand side. So we want to see, is there a greatest common factor between x squared, 4x, and 45? There's not. There's no, x squared doesn't have a number in front of it besides 1. 45 does not have a variable. So we would move on to our 2 sets of parentheses with 3 spaces. Now we can find our sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Here, since the third term is negative, our signs are opposite. Now we need to find the factors of the first and third terms. So the factors of the first term, factors of x squared, are going to be x and x. Factors of 45. 1 and 45. 3 and 15. 5 and 9. When I find the factors, I always start with 1 in the number itself and then start increasing the left side. So 2 is not a factor, it doesn't work. 3 and 15. 4 is not a factor, so we move on to 5, 5 and 9. 6 is not a factor. One of the main ways we know 6 is only going to be a factor if both 2 and 3 are factors. So 6 is not a factor. 7 we would have to try. 7's not going to work because it's way too close to 49, 7 and 7. 8 won't work, and then the next one's 9. We've got them all. Which one do we want to try first? 3 and 15. Now, before we start setting anything equal to 0, we want to make sure we have the correct factor. So off to the side, we'll check. X times negative 15 would be negative 15x. 3 times x is going to be plus 3x. Negative 15x plus 3x, negative 15 plus 3 is going to be negative 12. Is that the middle term we wanted? Now, we could try switching the 3 and 15, but that won't do a whole lot because the numbers in front of x are both 1. They're both the same. Not since because they're 1, they're the same number. What it would give us if we did flip it and check it would have been 15x minus 3x, giving us 12x. It would have just changed the sign. So which pair of numbers do we want to try next? 5 and 9. And again, we just need to stick them in and try it. X times negative 9 is negative 9x. 5 times x is plus 5x. Negative 9 plus 5, negative 9x plus 5x is negative 4x. Is that the middle term we wanted? Questions on this here? Now, the whole reason we solve this by factoring, we solve by factoring, because once we get it factored, we have two expressions being multiplied together that equal 0. The only way I can multiply two things together and get 0 is if either x plus 5 is 0 or x minus 9 is 0. One of these two has to be 0. Because our x plus 5, to solve it here, we would subtract 5 from both sides, telling us x is equal to negative 5. So if x is equal to negative 5, the equation will become 0. With our x minus 9, we would add 9 to both sides, telling us x is equal to 9. So if x is negative 5 or x is equal to 9, it tells us that x squared minus 4x minus 45 will be 0. Or it tells us that x squared minus 4x will equal 45. It will make that a statement true. Questions on this here? Questions on anything we've done so far? So we're going to solve this one here by factoring. 3x squared minus 5x equals 2. So we're going to subtract 2 from both sides, telling us 3x squared minus 5x minus 2 is equal to 0. Because if we wanted to graph it, we would have to subtract 2 from both sides and get it equal to 0. If we want to factor it, we need it equal to 0. The only method that we have so far that does not require us getting this equation equal to 0 is the square root method. Square root method won't work because we have an x squared term, but we also have an x term. I cannot have an x squared term and an x term and get the square root method to work. Now, once we get this equation equal to 0, we're going to look for a greatest common factor, something in common with every term. Now, 3x squared, 5x, and 2 do not have anything in common. So we'll move on to our two sets of parentheses with 3 spaces. Now we're going to find our signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Now we need to find the factors of the first and third term. 3x squared is kind of nice because the only factors for x squared are x and x. What are our factors of 3? 1 and 3. Where do you want to put the 3? 3. We just need to stick it to 1 in front of the x's because 1, we put it in front of the other. 1x and x are the same thing. Now we need to find the factors of the third term. Factors of 2 are 1 and 2. Where do you want to put the 2? With the plus or the minus? Plus. Now we can check and see if we have the correct middle term. X times negative 1 is negative x. 2 times 3x, 2 times 3x is positive 6x. Negative x plus 6x, negative 1 plus 6 is going to be positive 5x. Now that's not the middle term we wanted. It is the correct number, but it's the wrong sign. So all we need to do is switch the signs. Because if we wanted to switch the terms, we could do that, but we'd have to switch the x and 3x, the 1 and 2. We'd have to switch everything but the signs. Or we can just switch the signs. It's a little bit easier to switch the signs. Which will tell us that we have x times 1 is positive x. Negative 2 times 3x is going to be negative 6x. And this will indeed give us negative 5x. We switch the signs, which change the sign of the middle term. Now, the reason we factored and went about factoring is we wanted to get 2 or more things multiplied together to equal 0. Now, we're going to set each of these expressions that does have a variable equal to 0. So we'd set x minus 2 equal to 0. 3x plus 1 equal to 0. And we're going to solve. So with x minus 2, we can add 2 to both sides, telling us x is equal to 2. With our 3x plus 1, first thing we can do is subtract 1 from both sides, telling us 3x equals negative 1. Divide both sides by 3, telling us x is equal to negative 1/3. Questions on this here? Now, if we had graphed this, we would have found one of the 2 solutions. We would have found that x equals 2. We would not have directly be given the fact that x is also equal to negative 1/3. We would have seen that it does cross the x-axis between 0 and negative 1, but then we'd have to do a lot of different methods to try to get there. Now, we have 2 more. I might have miscounted earlier, but we have this one and 1 more, and then we are done for today. Now, this one here is telling us something a little bit different. It wants us to find the zeros of f of x equals 2x squared minus 11x plus 12. Now, we haven't talked about this up to this point. We haven't talked about finding zeros. But what we've been doing today and yesterday and with factoring and doing these methods is we're trying to find the values of x that will make this function equal what? 0. So those values of x are zeros. They are solutions. They're zeros. They're what's making the function be zeros. They are the x-intercepts because that's where it crosses the x-axis. And all the values of y at the x-axis are 0. So the x-intercepts are the zeros. And we're also trying to find the solutions. So the solutions, the x-intercepts, the zeros, are essentially the exact same thing. It's just the context of what we're looking for changes a little bit. So we're trying to find the zeros. We're trying to find out what values of x will make this function be 0. Now we can graph it, because we could grab the graphing calculator and hit pi equals. And we can type it in. So we can say 2x squared minus 11x plus 12. So we can type the equation in and hit graph. We're looking to see where it crosses the x-axis. What values of x will make the y value be 0? And as we look at this here, we see that it crosses the x-axis in 2 places. Second graph will give us a table, and we see that one of the values of x that will make this function be 0 is 4. However, it doesn't give us the other one. But we did see that it crossed somewhere around between 2 and 3. Yes? Now, in the table, we'll talk about this here. We'll talk about it more later. They have something called the intermediate value theorem. Sounds complicated. Sounds like there's a lot to it. And what it says is between 2 points, the y value goes from positive to negative, or negative to positive. The only way it could have done that is if it crossed the x-axis. Because at the x-axis, the y value is 0. So if the y value goes from negative to positive, it went from below the x-axis to above it, or it went from above it to below it, and the only way it can do that is if it crossed somewhere in the middle. That is literally what the intermediate value theorem says. If between two given x values, the y value goes from positive to negative or negative to positive, there must be some intersection between it. So we know somewhere between 1 and 2, there is a 0. So, told us one of them, we got to find the other. We're going to go on and just factor. Now, there is no greatest common factor between these three terms. So we'll have our two sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Here, the third term is positive, so the signs are the same and match the sign of the middle term. So negative and negative. Now we need to find the factors of 2x squared. Well, the factors of x squared are x and x. That's the only factors of x squared. Factors of 2 are 1 and 2. Are there any others? No. Where do we want to put the 2? With the first x or the second x? First x. Now our factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which one do we want to try first? We can try 1 and 12. And if we check this here, 2x times negative 12 would be negative 12x. Negative 1 times x is negative x, giving us negative 13x. So, that is not the middle term we wanted. We could flip the 1 and 12, but that's not going to work either. So let's try 3 and 4. Now, 2x times negative 4, 2 times negative 4 is going to be negative 8x. Negative 3 times x is going to be negative 3x. Negative 8x minus 3x is going to be negative 11x. And that's the middle term we wanted, yes? So it's telling us that is the correct factors. We also know, because of the zero product property, if I multiply 2 or more things together and get 0, one of them has to be 0, yes? We'll start with the one on the right. So the first thing we can do in solving for x is to add 4 to both sides, telling us x is equal to 4, yes? Well, graphing told us one of the values of x was 4. So it kind of gave us a hint at what one of the solutions was going to be. Now, 2x minus 3. First thing we can do is add 3 to both sides, telling us 2x is equal to 3. Quickly. Divide both sides by 2, telling us x is equal to 3 halves. So the one it didn't give us was 3 halves, but yes, because when we saw the graph, we did say it was between 1 and 2. So we do know that is the correct answer. It's just it wasn't given to us directly from the graph. Questions on this here? You ready for the last one? We're going to look at f of x equals x squared minus 8x. If we're finding the zeros, we're trying to find out what value of x will make this function be 0. Now, when we graph, or we're going to factor this here first. Because first thing we need to do in graphing is get it equal to 0. We're already there. Then we need to see, is there a greatest common factor between x squared and 8x? It actually is. What do they have in common? They both have an x, yes? Because up to this point, the only greatest common factor we've really factored out is a number. There's nothing saying that we can't factor a variable out. But if you think back to all the quadratics we've had an x squared and a term without x. So we haven't been able to factor a variable out. Here, we don't have that constant term. We don't have a term without a variable. So we can factor that variable out. If we factor an x out of x squared, we're left with x. If we factor x out of negative 8x, we have negative 8. Do I have two things multiplied together that equal 0? So we're saying that either x is 0 or x minus 8 is 0. Now our x minus 8, we'll solve it first. First thing we can do is add 8 to both sides, telling us x is equal to 8, yes? The other equation. X is already by itself, yes? So x is 0. So for this here, x is 0 and x is equal to 8. And that is it. We are done with 3-3. These problems are posted in Google Classroom, so if you need to look there, you can. Y'all have a good rest of your day.